Hey y'all, in this video, I'm gonna go ahead and try to clarify some things about what the resultant is and the displacement and why we have all these right triangles everywhere. But I'm gonna start with some just regular vectors so that we can lead into the rest of this. So this vector, I don't have the magnitude listed, but it's at 15 degrees north of east. If I have this as part of one of my bigger things, then I need to break it down into the vertical and horizontal components. Okay, those are just the pieces. To do that, that's when we do sine and cosine. Okay, in order for me to do sine and cosine, I have to have a right triangle. So that's why I always draw these so that we can see where our right triangle would be. Okay, your angle, you always want to make the horizontal here, and then you're going to go vertically, whether it's up or down. Then when I'm looking at this, I have two components. This would be dy, because that's the vertical component, it's up and down. This would be dx, it's the horizontal component because it's side to side. Okay, then when you're trying to figure out if you're using sine or cosine, you need to see where your angle is. This is the angle that I have. dy, the vertical component, is opposite this angle. And you can also write SOHCAHTOA up here, but because it's because it's opposite, I know that I need to use sine for this one. So to get this, I would do my magnitude times sine 15. That gives you how long this dotted line is. Okay, same thing down here, it would be the magnitude times cosine 15, because here's the angle and this is the adjacent side, and adjacent would be cosine. Okay, for this one, you have this 28-degree angle. You're gonna draw your horizontal first. This would be a dotted line, okay, and then your vertical line. So when I draw a right triangle for that vector, that's where it's gonna be. Now for these, I have two vectors together. When you are drawing your dotted line for the resultant, okay, it's the same as the displacement, and that's your start to end dotted line that you draw first. Okay, so from start to end, let's see how it goes from the start to the end. Okay, a straight line that goes from the start to the end, and we do dotted just so that we don't get it confused with the other ones. That is going to be the hypotenuse of your big right triangle. You have to find your big right triangle first in order for you to be able to do Pythagorean theorem and your inverse tan. I'm going to write these things here for you, and that's opposite over adjacent. Okay, if you don't have the sides of your right triangle and your opposite and adjacent, you're not going to be able to find your resultant. Okay, that's what we're trying to do for these. This is your resultant, this dotted line. But in order to solve for that, you need the magnitude of it, which you need Pythagorean theorem to find, which means that you need a right triangle. And then you will do the inverse tan. But you have to have a big right triangle. Okay, right now, this is an obtuse triangle. It's not a right triangle. So in order to do that, I'm gonna say that this dotted line, remember the start to end dotted line is the displacement, and it's going to be the hypotenuse of the big right triangle. So I know that I need a right angle in here somewhere. Okay, you can basically already see this part of it. If I extend this down and extend this, then I would have a huge right triangle. Okay, you could go this way. However, in physics, we typically will do the horizontal line first, so that when I'm finding the angle, it's the angle from the horizontal. If you do it the other way, that's fine, but your angle is going to be from the vertical. Okay, so I will always choose to do it from the horizontal. So I'm just drawing these out to show this is my right triangle. This entire thing is what I'm dealing with. This is what I'm trying to find. This is the resultant. That's the displacement. It's asking me for the magnitude and direction of the displacement. You find the magnitude by doing Pythagorean theorem once you have these sides, and you're going to find the direction by doing inverse tan once you have those two sides. So that's what you have to figure out first. Okay, figure out where your big right triangle is. From there, it's just this little part. Okay, notice that these triangles look almost the same. The only difference is this angle here. Okay, so you're gonna figure out dy, figure out dx, and then if you have to add any pieces together, that's what you do. You're gonna add this, and that'll give you the total. So that would be either A or B for your Pythagorean theorem. And this part is gonna be the other option that you plug in here.